Hey, what's up everybody? This is Ray. Welcome to our beginner OpenGL ES and GLKit video tutorial series. In this tutorial series, we'll show you how to get started with OpenGL ES to render some 3D geometry to your screen and even make a simple game, even if you're a complete beginner. Let's start by covering what is OpenGL ES and what is GLKit anyway. So your iPhone comes with something called a graphics processing unit. And this is a chip that's very efficient at processing high amounts of vertices and 3D geometry very efficiently and rendering them to the screen. Well, the lowest level API that interacts with this GPU is OpenGL ES. And that's what we're going to be learning about in this video tutorial series. So let's say you want to make a game for iOS. Well, what should you do? Well, there's a couple different options that you have. One is you can make a game that sits directly on top of OpenGL ES, and that's actually what we're going to be doing in this video tutorial series. And in the old days, this was the only way to make games on iOS because there weren't a lot of good game frameworks available yet. Another thing you could do is Core Animation and Core Graphics, the libraries written by Apple, are actually on top of OpenGL ES, so they're still getting the benefit of being accelerated and very fast rendering to the screen. And on top of those frameworks is another framework called UIKit, which controls the UI views and buttons and controls that you know and love. So you could build your game on top of that stack as well. And a lot of simple games, especially card games and the like, are built on top of the Apple stack there. Now, since iOS has been released, a lot of great third-party game frameworks have come out, most notably Cocos 2D, iPhone. So that is just literally some code that sits on top of OpenGL ES that makes your game easier to code than using that lower level API. So you can use a third-party framework, but you just know that you're still using OpenGL ES commands under the scene. Even Unity, targeted for iPhone, is still using OpenGL ES to render to the screen. Next, Apple's come out with their own game framework called SpriteKit, and that, yet again, is just another simple abstraction layer on top of OpenGL ES tailored toward 2D games in this case. And last but not least, you might wonder, okay, well, what's GLKit? You might think, well, given the other examples, it's probably just some kind of library that sits on top of OpenGL ES that makes it simple to make 2D or 3D games. That's actually not the case. Think of GLKit as a very, very thin helper library with some helper functions inside it. And we'll get more into exactly what's inside there later. But it's not really doing too much for you. It's just taking a few tedious tasks and making them easier to deal with. But really, you're still writing OpenGL ES code mostly. You're just saving yourselves from writing a few little bits here and there. So after the previous section, you might be wondering, why should I bother learning OpenGL ES and GLKit anyway? It looks like there's all these other great frameworks that I could just build my game on top of instead. If that's what you're wondering, I actually would agree with you. I don't recommend necessarily making your game on top of OpenGL ES directly anymore, considering there's all these other great frameworks available and they'll save you time and energy that you could be better spent focusing on your game. However, I do think there's a lot of great reasons to learn OpenGL ES anyway. First of all, there's the raw learning. The process of learning OpenGL ES will teach you so many things that will be useful for you for so many different reasons. To learn OpenGL ES, you're going to have to learn some things about 3D graphics. You'll have to brush up on your math and linear algebra a bit. You'll learn about the API itself and what's going on under the hood with your games. So it's just really rewarding and enriching, and I think you'll have a really good time learning all this stuff. Next, there's customization. So even if you're building on top of another game framework like Cocos 2D or Unity, like I said, under the hood, they're still issuing OpenGL ES commands. And a lot of these frameworks allow you to write your own OpenGL ES code where you need to, but leverage the rest of the framework where you can as well. And in fact, this is what I did for one of my apps called Battle Map 2. This is an app that lets you draw maps for geeky D&D players like myself. And the way I wanted this app to work is when the user drags their fingers, they fill in a map with tiles. But I wanted it so that when you draw a tile, it sort of beautifies the edges around that tile to look nice and rounded, as you can see in the screenshot here. And I want to do this in an automated manner. And to do this, I needed to write some custom OpenGL ES code that efficiently took images and masked their edges and put them together in a smart and performant way. And this is something that was not built into Cocos 2D, so I had to dive down to a deeper level to OpenGL ES and do that. And because I had the OpenGL ES knowledge, it allowed me to do that in a great way. And similarly, for even Unity, you can write your own shaders that interact with Unity and so on. So it's going to be helpful to you when you need to customize things. Next, there's performance. So when you're working on your games, you might hear certain rules the programmers say. Like they say, it's important to use sprite sheets for your game. And you might not necessarily understand why is that important and what's going on behind the scenes. But when you start studying OpenGL ES and you see, oh, okay, to render a sprite, well, first I have to bind that texture to be the active one. And by doing that, that has a performance hit. So if I'm constantly switching between textures, that's constantly causing that performance hit. You start thinking about these things and you start better understanding how to make your game work well because you understand what's going on at a lower level. Next, there's portability. So OpenGL ES is a cross-platform API. It's written in C. So if you're careful and you write your code in C++, most of your game logic in C++, it would be relatively straightforward to take that code and port it to another platform, say Android, for example. So that said, if portability is your main concern, I will note that some of these other APIs that are available, they also have cross-platform support. Most notably Unity, very easy to get it to work on different platforms. Even CocosD has something called App Portable, which lets you do that, and App Portable will be supporting SpriteKit fairly soon as well. So it's not as much of a thing if that's your main concern, but it is a good advantage to keep in mind. And last but not least, there's the raw power. So like you saw in one of the earlier sections, the only thing between you and the GPU is OpenGL ES itself. There's no extra boilerplate framework code. There's no extra cruft. You know exactly what's going on. You have complete control. So if you want to do something really pushing the edge, it's a great way to go. If you've ever tried to learn OpenGL ES in the past, you might have come to the conclusion that I did when I was first learning it, which is learning OpenGL ES is just hard. And here's why it is. First of all, there's not a lot of up-to-date books or tutorials on the subject, actually. When you're searching for OpenGL tutorials, a lot of times you'll come across tutorials targeting OpenGL ES 1.0, which, as you'll see, is really very, very different from OpenGL ES 2.0. And when you're looking as a beginner and you see one of these older tutorials, seeing that old code that does not work at all on OpenGL ES 2.0 just confuses the heck out of you. Next, there's not a lot that are especially iOS specific. There are some good tutorials out there that are targeting OpenGL ES 2.0 or later. But the problem is they're not written for the iPhone. They're written for, say, Linux or Windows or something like that. And the process of trying to get that code from that tutorial from Linux or Windows over to the iPhone as a beginner, that can be quite challenging and quite confusing. And not to mention, there's a difference between OpenGL, plain OpenGL, and OpenGL ES. And some of the tutorials just target plain OpenGL, which adds another layer of confusion to the mix. For the books and tutorials out there that do cover OpenGL ES, some of them just cover OpenGL ES and they don't mention anything about GLKit, which I think GLKit is really helpful and important to know, and so I don't think you should just skip over it. Similarly, some books just focus on GLKit and they try to hide the complexities of shaders from you, but I think that's really important to understand as well. And a lot of these books and tutorials, they show you how to render a triangle or a box, which is great. I think that's actually one of the best ways to get started just because it's so simple. But they never show you how to go from the triangle to the box to, say, a 3D model from like something like Blender, and finally how to make a game out of all of this. And so you're missing those sort of linking steps and you're left on your own for that. So that can be quite confusing. There's also, most of these have little hands-on focus. They might walk you through, how to do one thing, but there's no practice or anything on your own. And last but not least, no matter what you do, learning OpenGL is just hard. It's just because there's an API. It's sort of a complicated API. It interrelates to the graphics card and what's going on there. There's a lot of math involved. So no matter what people do, it's still going to be hard. And so by the time you get through all this, you might feel like this guy. How am I ever going to learn this stuff? Well, that's where we come in. So here's the approach we're going to take in this video tutorial series. First of all, this series is completely up to date to the latest version of iOS at the time of making these videos and the latest version of Xcode. It's also fully iOS specific. All the code you can just download, run right on your iPhone. Next, we're going to cover both OpenGL ES and GLKit because I think both are important to use and understand. By the end of this series, we're going to make a simple game that takes everything that you've learned and sort of puts it all together so you can actually see something interesting happening. We're going to have lots of demos. Every time we're going to have a demo where sometimes we'll have quizzes to sort of make sure you understand the concepts. And every section will have a hands-on challenge or lab associated with it. And I think you'll find those really fun. And in the end, it's still going to be hard. Like I said, there's a lot to learn here. But the goal of this series is to provide you with a solid starting point, some examples that work, get you kind of inspired that you can do this and you can learn OpenGL and make some cool stuff with it. So by the time you're done this series, you'll have a firm understanding of the basics of OpenGL, and you'll have practiced it quite a bit. You'll learn how to render a simple cube to the screen. You'll learn how to add texturing and lighting to that cube. You'll learn how to create a model in Blender and import it into your game. And finally, you'll have learned how to make your own simple 3D game. Now, there are three things that are non-goals of this series that I should point out. First of all, OpenGL ES is a C-based API, and so I'm not going to be covering the syntax of C programming. So if you're unfamiliar with C programming, I recommend you go through a tutorial or a book on that first so you're not confused by the syntax as you go through this series. Secondly, we're not really going to dive too deep into linear algebra. I'm going to mention some linear algebra concepts, but they're going to be more from like a high-level black box type perspective to make things easier as you go through this series. If you're really interested in learning the under-the-hood details of linear algebra, I recommend studying up on that, and the book that is listed here is actually, I think, a really great introduction to the subject. And last but not least, we're not going to go too deep into shaders. Now, we are going to cover shaders because I think that's really important, but the examples we're going to cover are mostly very basic shaders. If you want to learn more, that could be literally an entire series on that, and there's a good book that I have pictured here. Do note that it's a book on OpenGL, not OpenGL ES, so there's going to be some differences there, but it's still quite helpful. Next, let's cover the history of OpenGL ES on the iPhone, because there was a big transition between version 1.0 and version 2.0. Version 1.0 is the first version of OpenGL ES that came out on the iPhone. Let's take a look at what this looked like. This is a picture of what the graphics pipeline looks like on OpenGL ES 1.0. At this point, it's not important to understand what all these words mean. You'll be learning about those in this series. All I want you to see right now is that there's two green areas in this picture. The first is transform and lighting, and the second is texturing, color sum, fog, and alpha test. The important thing to understand is that in OpenGL ES 1.0, whenever you wanted to do something that had to do with the areas inside these green boxes, there was a function that let you do that. For example, if you wanted to set a transform, you would call a function to do that. If you wanted to set up a light, there would be another function to set up a light. If you wanted to set a texture, well, there was a function for that, and so on. When OpenGL ES 2.0 came out, there was a major change. You'll see here that the pipeline looks very similar in the blue and the purple boxes. However, the green box has completely changed. In OpenGL ES 2.0, they took out all of those functions that were built in, those fixed functions. And instead, they've introduced a programmable pipeline. So instead of having built-in functions to do transform and lighting, you have to write your own code, your own little programs called shaders. And there's a vertex shader and a fragment shader that you have to write to do the equivalent of what you used to do. So instead of having built-in functions for transform and lighting, you write some shader code to do transform and lighting. Instead of having built-in functions to do texturing, fog, and so on, you write your own code to do that. As a beginner to learning OpenGL ES, you might feel like this guy. You might say, wait a minute, why are you making me write everything in OpenGL ES 2.0? I liked it better in the good old days, where whenever I wanted to do something with transforms, I could just call a function, and whenever I want to do something with textures, I just call a different function. Now I got to write all that code all over again? What's going on? So the disadvantage of 2.0 is that you have to write your own shader code, which adds a little bit more complexity to the mix. But the advantage is by allowing you to write your own code to do all this stuff. Really, the sky's the limit for the types of effects that you can produce. So here's some pictures of effects that could only really be done in OpenGL ES 2.0 with this programmable pipeline. The first is a cartoon shader. I'm sure you've seen this in some games for the gamers out there, like Borderlands, for example, popularized this. The other picture is an example of a nicely shaded model from Quake that's done on the iPhone here, and you can see there's some nice lighting and shadowing and stuff like that. These things would have been very difficult or impossible to do with OpenGL ES 1.0, because when there are fixed functions for everything, you can only do what is expected and allowed by those fixed functions. But if you can write your own code to do something, really the sky's the limit. And remember, these functions that you're writing for these shaders are running on the GPU, so they're very fast, very efficient, and you can get some very cool effects. Okay, so as you've seen, there's been a huge shift between 1.0 and 2.0, and the code just is completely different. There's now the concept of shaders. If you're wondering, should I be using 1.0 or 2.0, the answer is very clear. Every iPhone device that's really used these days has OpenGL ES 2.0 support by now. So you should be using OpenGL ES 2.0. There's no reason to be using OpenGL ES 1.0 anymore, or learning OpenGL ES 1.0. I recommend diving straight into OpenGL ES 2.0 Plus. But that might make you wonder, okay, well, I've heard about OpenGL ES 3.0. What's going on with that? Which should I be learning or using? Well, let's go through that. So first of all, notice that OpenGL ES 3.0 at this time is only available on some iOS devices. It requires the Apple A7 chip or higher, which right now is only the iPhone 5S, the iPad Air, or the iPad Mini. The second thing to understand about this is that unlike OpenGL ES 1.0, OpenGL ES 3.0 is upward compatible with 2.0. In other words, if you write a program that works with OpenGL ES 2.0 and you later decide you want to target 3.0, all you have to do is change basically one line of code to switch from using 2.0 to 3.0. So everything you're learning with OpenGL ES 2.0 applies directly to 3.0. The main difference is OpenGL ES 3.0 introduces some new features tailored toward optimizing high-performance 3D games. So some examples are, first of all, there's occlusion queries. This is a way to tell, is an object behind another object so you can't even see it? Is that the case, then you can just skip rendering that object and sort of save some time. Another thing you can do is transform feedback. This lets you efficiently create some particle systems on the GPU rather than having to have CPU code be updating their positions and so on. Next is instance rendering, which makes it efficient to make multiple copies of the same object in a lot of spaces through your scene, like trees, for example. And next is multiple rendering targets, which let you render, say, the screen and a texture at the same time in a more efficient manner. So as you might guess from the way I've listed those 4 items, those are kind of like advanced features that you don't even nearly need to be concerned when you're learning OpenGL ES. Like right now in this series, you're focused on how do I get a triangle onto the screen? How do I get that to be a 3D cube? And then how do I make a simple game? You're not even worried about these more advanced features here. So between that, the fact that these are more advanced features you don't care about at the beginning, and also that it's not available on iOS devices, I recommend that right now you focus on 2.0. Everything you learn in 2.0 will help for you and when you're ready to switch to 3.0 and use some of those advanced features when you need them. The other thing to keep in mind is you need to do 2.0 anyway, because since it's not on every device, the only way you can use 3.0 is by saying, okay, does this device have 3.0? Okay, use 3.0, but if not, I still have to fall back to 2.0. So we'll be focusing on OpenGL ES 2.0 in this series. Next, I want to say a few things about GLKit. I mentioned earlier that GLKit is that thin little helper library that helps you save time on some common OpenGL ES tasks. But I wanted to go into a little more detail on that and what we'll be covering in this series and what we won't. So first of all, there's GLK View and GLK View Controller. You can think of these as some helper code to sort of get set up, initially set up with OpenGL. And I think if you're targeting the iPhone platform, there's no reason not to be using this. It just saves you some time, gets you started nice and early, and works real well. So we'll be focusing on that. The next is GLK Math. This is a handy 3D math library that you can use to do things like matrix math, vector math, and so on. And if you're going to make a 3D game, you're going to need a math library. So why not use this one? It's full-featured and it's really optimized to run well on the iPhone platform, so it's definitely another great win. The next is GLK Texture Loader. Without this, you'd have to write some annoying code when you want to load textures that loads graphics from using Core Graphics APIs and gets them into the format that OpenGL knows and expects. It was kind of just annoying boilerplate code. They've abstracted this into a helper class, so I really recommend using that as well. Now the last one is the one we're not going to cover, and this is called GLK Base Effect. The reason GLK Base Effect exists is because, remember the history of iOS. Everybody had written their games to target OpenGL ES 1.0 in the old days, and Apple wanted everyone to be able to transition smoothly to OpenGL ES 2.0. The problem is, in 1.0 you didn't have to write shaders, in 2.0 you do. And shaders were, something people had to learn, and when they just wanted to get their game ported quickly, they didn't necessarily want to write their own shaders. So what GLK Base Effect is it's basically some shaders that implement the fixed function pipeline that was available in 1.0 to make it easier for people who have 1.0 games to port their code to 2.0. So without necessarily having to know shaders. But in this series, I think it is very important to know shaders, and I think rather than trying to hide the complexity of shaders from you, we should just bite the bullet and get into them right at the beginning. So we're not going to be using GLK Base Effect because we're going to be writing our own shaders instead. Every section in this series has a hands-on challenge associated with it. And I really recommend you take the time to go through those because it'll help you reinforce what you've been learning in these tutorials. So there's two parts to each of these challenges. The first is a hands-on walkthrough, where it's like a tutorial on our site where we sort of guide you through mostly step-by-step and what you need to do. And the second is what I call the Uber Hacker Challenge. And this is for the overachievers out there who really want to push your knowledge and skills a little bit further and see what you can do. And these are not step-by-step, but for both of these, I do have solutions available if you get stuck, but don't cheat. Last but not least, here's an overview of what we're going to be covering in this series. First of all, we're going to start with a Hello OpenGL, and we're going to do the simplest possible thing we can do, which is just color the screen like a green color. Believe it or not, it does require more than one line of code to do this, but it's not too bad. So we'll get started with that. Next, we'll say, okay, now that we have things sort of set up to use OpenGL, how do we render a triangle to this screen? And you'll be learning about vertex buffers and attributes to do that. After that, we'll say, okay, now that we have a triangle, how can we make it a colored triangle and actually make it colored square instead? And in this, you'll be learning about shaders and the graphics pipeline on the iPhone. Next, you'll be learning about up to this point, we've written our code kind of all in one view controller to make it nice and easy. How can we architect our code to be a little cleaner so that we can actually support more complex ideas like eventually games in the future? And so there you'll be learning how to make your own node class and also use vertex array objects to sort of make your code a little more performant and clean. Then we'll get into 3D transformations, finally taking that 2D square, moving to the world of 3D. And we'll also be going into texturing and lighting at that point. And then we'll get into Blender. How can we make an object in Blender, get it to show up in the app? And last but not least, at this point, you believe it or not, have all the pieces you can then put together to make your own simple game. So we'll make a simple breakout game for the iPhone. All right, that's it for this video. This was really just an introduction to show you what's going to be coming up in this series. So there's really no true challenge associated with it. But I will say your challenge is to just keep watching this series and see what you can learn about OpenGL. So I hope you enjoyed this introduction. Thanks for watching, and we'll see you next time.